I'm MC2 and welcome to my channel. Anti-5G scammer Mark Steele has put out a video and it is incredibly wrong. Everything in it is wrong. In fact, some of the things in his own video debunk himself while it's on the screen. Oh, he can't get anything right. I was going to respond to it, but Leigh Porter, my good friend Leigh Porter, did it already, and I could not do better than Leigh did. So what I'm going to do is instead, I'm going to play Leigh's video after this. So watch it here, or better yet, watch it on his channel, and I'll put the link to his channel in the description. But I'm going to ask you, this is an audience participation video. After you watch it, or during you're watching it, I want you to take the link to Leigh's video and put it in the comments for Mark Steele's video. Mark Steele's channel is The Lion Roars. He thinks he's Aslan or something. He's got a crown on this lion's head. So put it in his video, because Mark is a scammer. And a critical part of scamming people is to not let them know that they're being scammed, to not let them know that the guy scamming them is wrong about everything. So if you paste that link with a special message to Mark or anybody that's following along, that it's a scam and that he's wrong about everything, that will, it will let any potential future victims of Mark know that he's not on the level. Now, I'm not asking, don't insult Mark, just something informational, please. So both of those will be in the description, right? So do that. And hopefully it can dry up the source of Mark's future scam victims. So here it is, Leigh Porter.
Hi, it's Leigh again, back into the lab. Again, not in the basement because it's still freezing, so I'm in the inner sanctum of the lab. What I found is Mark Steele has released another video on YouTube. The title is Trolling This One. Easy for people to see through the trolls and their continual lies. The irony isn't lost on me there. But this video is, it's so full of, well, we'll see, won't we? But I thought the best way to look at this video would be to play it for you. And every now and again, I'll pause it and just show you what is actually happening there. So let's get started.
Morning, everybody. Well, there's no doubt anybody that's following quite a number of the videos that have kicked around. Obviously, Brigade 77 and some very distasteful people are absolutely in a panic about this leaf nut technology. All right, very, very getting himself pretty excited about it. And I'm pretty trying to work out what the real reason is. But obviously these self-confessed con men, right, some very distasteful, we need to put them in that box, right, because a lot of confusion, they're putting up a load of complete nonsense, fraudsters. And what I'm going to try and explain to people, look, this is the leaf nut technology, all right? Capable of interfacing a number of smart city services, control and monitoring such applications as pollution. Interesting, pollution parking. So you can see cars parked, winter maintenance, that's basically look at snow on the ground, smart waste collection and flood detection, and you see rain on the ground. Now, how do you do that? Capable of backhauling data from a multitude of devices in a built environment. That's 5G, by the way. All right, backhauling means basically spying on all your equipment. And that's what this equipment's capable of. This is radar. It's urban scanning radar. Not as the trolls say. This is from leaf nut themselves, such as car parks, pedestrian walkways, campuses can be controlled and monitored. They can control the light radiation from the LEDs as people walk into the area.
Okay, so let's take a few of the things that Mark says there. So leaf nut is indeed the product of a company called Harvard Technology. I have one of their devices here, which I had a look at on a video which I'll upload as well this evening. This is one of the devices here. It goes on the top of a lamppost and it turns the light on and off, and sends back data such as, is the light working, how much power it's using, etc. Some of the ones that work with LED lighting can do more than turn it on and off. They can also dim the lights, so they're not using as much power, and also they're just not as bright on the road. So that's what this is designed to do. So Mark says a couple of things. First thing he says is that it can help with things like pollution, parking, winter maintenance, smart waste collection, flood detection. And these are all good things to do. How would it do that? How would it monitor such applications as pollution? Well, we have NO2, CO2 and diesel particulate monitors around London, for example. And what they would do is they would connect those sensors to a leaf nut device. And every now and again, they would send back stats about the levels of those gases and those particulates. That's what it does for pollution monitoring. Parking meters can connect to the network, and potentially you can have smart car park spaces that know if the car's parked there or not, which is really handy, because then if you're trying to find a parking space in a busy area, you could potentially have an app which tells you where there is a spare parking place. Smart waste collection. Where I live here, we have some municipal bins, and sometimes they're full to overflowing. It'd be great if they could know when a bin is actually full, and they could send people to empty the bin when it's full, rather than just every couple of weeks or every week or so. How would it manage flood detection? Well, quite easy with water sensors. If you have an area that's prone to flooding, or if you have rivers that are prone to flood, they can put water level sensors there, and they'll get an early warning of when that water level is rising to a level which might cause flooding in the area. And the last bit he talked about was it's capable of backhauling data from a multitude of devices in the built environment. Well, yes, so the devices could be parking meters, flood sensors, pollution sensors, and it backhauls that data to their monitoring sensor or whatever they have there at the council, and they can then monitor that data remotely. What does backhauling mean? We'll have a website here, and let's look at the definition of backhaul. What does it actually mean to backhaul data? So here's the backhaul website. In a hierarchical comms network, so hierarchical means you have a layer at the bottom of the network, which is where your users access the network, such as Lamppost on LoRaWAN, or a device which is collecting pollution data. And the backhaul is a bit from those devices that go up the network. So backhaul is just backhauling the data across the network. It isn't spying. Backhaul has been used since 1G phones came out, and the backhaul is just the network that takes the data from base stations to the rest of the core network. Then he spoke about the last paragraph in that document there, and it speaks about the bit underlined. He says, such as car parks, pedestrian walkways and campuses can be controlled and monitored. Of course, it's for lights that are controlled and monitored. So all it means is that if you have an alleyway somewhere, then the iNut, which is a device that they released called, I think it was called the sensor node. And what a sensor node does is it's basically one of these things here, but it has an extra bit in it, which is a presence detector. And that could be a number of things. It could be a passive infrared detector, for example, which just detects your body heat moving around. And what that does is it overrides the typical settings for that light. So it might go on at a certain time, go off at a certain time. It overrides that, so it will just turn on. So if somebody is going to go into that alleyway, that dark alleyway, then the lights will automatically turn on, so they have some lighting there. And that's all it is. That's what presence detection is. But you see, it says here, the device operates via connection with an external presence detection unit. That Harvard Electronics device here, that does not do the presence detection. It is not a scanning urban radar device. That is the leaf nut node, which communicates with the network. the presence detection is a completely separate external device. Let's see what more he has to say, shall we?
But let's just go on a little bit more, because we need to smash these complete fools. We had one clown, what he said was 868, these spectrums not used for 5G. Well, unfortunately, as it says there, enabled by 5G.
Okay, so that is a slice of spectrum. It's the roadmap for IoT spectrum access, and that can be obtained from Ofcom, and you can also look at the Ofcom frequency map, which we'll look at in just a second. So what do we have here? The bit that Mark highlights is this. It says IoT encompasses a broader set of applications and use cases than those enabled by today's mobile cellular networks. However, new IoT use cases will be enabled by 5G, since and we don't see the rest. So yes, new IoT cases might be enabled by 5G, but these leafnet devices were installed in about 2012, before 5G was even a thing. In fact, in 2012, 4G networks were only just beginning to launch. So Mark is making this document say something that it simply does not say. Let's see what else he says about this.
All right, so this is the spectrum used for 5G.
The spectrum used for 5G. Let's have a quick look at that. Let's look at the 868 megahertz spectrum on the Ofcom spectrum map. Here it is. Here's the range of 860 to 870 megahertz. And what we can see is that the bit we're talking about here is 868-ish. The actual Harvard device that I have and tested works on 869.5 megahertz. So on 869.5 megahertz, what do we have here? It says non-specific short-range devices. It doesn't mention 5G. In fact, 5G is not mentioned anywhere here in this spectrum map. So there's no 5G here whatsoever in the Ofcom spectrum map for that portion of spectrum. So Mark is quite simply here making this document say things that it does not say.
All right. They need to get the facts right, don't they? 800 and 900 megahertz. Right. This is the Zigbee operating platform, and that's one of the main operating platforms for the 5G.
What does he say about Zigbee?
As we know, but they seem to just not be able to do their homework properly.
So Zigbee is a main operating platform for 5G. I'm not quite sure what he means by those words. Let's have a quick look at what Zigbee actually is, shall we? Zigbee here is a Wikipedia page, but it explains Zigbee perfectly well. Zigbee is an IEEE 802.15.4 based specification. So it is not a FreeGPP specification. We'll look at that in a bit. FreeGPP are the group that defines the 5G specification. So Zigbee has nothing to do with 5G. It's a suite of high-level comms protocols used to create personal area networks with small, low-power digital radios, such as for home automation, medical device data collection, and other low-power and low-bandwidth needs, designed for small-scale projects which need wireless connection. That's what Zigbee is. Zigbee has nothing to do with 5G, Mark.
It's an Ofcom document. Look, 5G can be also rolled out in bands with existing authorization, such as bands currently used for 2G, 3G and 4G, as long as it falls within the technical parameters. What are those technical parameters? Well, the main technical parameter for 5G is actually focused energy in air, as we all know. And how you do that, use these type of lenses that are fitted to the antenna in these high gain strips. Now,
so he says the main parameter for 5G is focused energy in air. Mark hasn't found a reference for that anywhere because it is not a main technical parameter of 5G at all. The main parameters of 5G are found here. This is the FreeGPP website. From here, you can download the entire specification set for 5G. Here we are. So 5G started with FreeGPP release 15 in 2019. So I'm not sure where Mark gets this main technical parameter for 5G from, of being focus energy in air, because that isn't mentioned anywhere in the actual 5G specification set. You can download it yourself, have a look at it, see if you can find focus energy in air anywhere in their document, because it simply isn't there. It doesn't exist. Mark has made this up, and I'm not quite sure where he made it up from, because he won't tell us.
This is a PCB antenna, so it's a high gain microstrip printed onto this PCB. The PCB, right, is a resistor, massive resistor. So consequently, there's...
So I've already produced a video, and so has MC Toon, debunking this. That is not a microstrip antenna. Microstrip antennas are a specific antenna configuration, which this is not. So look at my other video and Michael Toon's video, which I'll put in the detail section of this video, and you can see this antenna is completely debunked. It is not at all what Mark says it is. It is a very simple vertical antenna. It's one in here, actually, the same one. It's an omnidirectional low gain antenna at 869 megahertz. But let's see what he says about this antenna, shall we?
Nothing on the back side of this antenna, the other side, so it's totally, it resists any radiation pattern going through here. Now, you may get some leakage, however...
No, it doesn't. It is electrically resistive, so it's an electrical insulator. It is not an RF insulator, because that would be impossible. It's just it's a piece of fiberglass board. The actual spec board is a FR4. You can look at that spec. It is fiberglass board. Fiberglass does not block RF, as you probably know. What does block RF is metal. And so in one of the videos I made earlier, I took this very antenna and I put a metal reflector behind it. And you could see then when you turn the antenna around that when the metal reflector is between the antenna and the signal goes down, because that metal reflector reflects the energy back and doesn't let the energy pass through it. Unlike this bit of circuit board here, which is an electrical insulator, but for a radio signal at 869 megahertz, it is pretty much completely transparent. And again, my video demonstrates this, that when you turn the antenna around 360 degrees, when the back of the antenna, which is the bit with the circuit board on, is facing the signal doesn't go down, and so it is not being blocked by that bit of circuit board.
The main drive of the antenna here is at 180 degrees from this flat plane, all right? Just basic science.
So he says that the radiation pattern is 180 degrees. What he's saying there, and it is incorrect, is that if you have I'll get it again. If this is the antenna you have here, then it will only transmit and receive, or it'll transmit and receive most effectively 180 degrees from the antenna. So if that's the antenna there, it will transmit and receive this side, but not this side. And he says that it is high gain. If you have an antenna with a 180 degree beam width, that is not high gain. That is very low gain, really. This antenna, of course, is even lower gain because it is actually omnidirectional. It is a 360 degree antenna, because that is the nature of a quarter wave ground plane monopole antenna such as this, which you can see again in one of my previous videos. Mark again is mentioning a little blob at the end. The little blob, again, I'll direct you to one of my previous videos. What the blob is a drip of conformal coating. It's like a kind of varnish lacquer that they dip the device into, a drip of conformal coating. And again, that's in one of my other videos, which I will link to in the description of this video.
Obviously a little bit difficult for the trolls to get their head round, because what they're trying to do is spin everybody a yarn, all right? They say that 5G is not rolled out in Lamppost. This is the Lamppost in Gateshead, by the way.
No one said that 5G is not rolled out on lampposts. What we said is that 5G is not rolled out on the lampposts with the Harvard devices on in Gateshead, which is what Mark Steele claims. And we know that it is not rolled out on Lamppost in Gateshead because the 5G specifications that only became standardized really about 2017 and probably ratified about 2019, which is very recently with the latest release at that time. And these were installed in about 2012 and first released 2007. So quite a long time before 5G was actually a thing. And we also know they're not 5G because the chip in here is a SI 1000 device, and I haven't got it here because it's still on my test rig, but it's one of the little chips on the boards, about that sort of shape there. And that is a general purpose RF transceiver chip with a maximum power output of about 100 milliwatts. It's down to about 25 for this application, and it has a CPU core on, which is similar to the CPU core used in a Commodore 64 computer, if you remember those. So there's two issues. One is that it's not on a 5G frequency. Three issues. One, it's not a 5G frequency. Two is that it was released and designed before 5G existed. And finally, it isn't actually a 5G chipset. The chipset on the device is not capable of the signal processing required for 5G.
And that has 5G. We got that, early doors of the lunatic. What they didn't understand was the 868, the 870, look, Automotive. See that at the bottom? Automotive. Very interesting part of the spectrum used for automotive because obviously you need the focusing antenna to fire at the car.
Well, you don't really. In fact, that would be quite a bad thing to do because the car's moving. And if you have this antenna here, and if it's highly focused, which it isn't, he's kind of contradicting himself there because 180 degrees is not highly focused. If you have a antenna that only transmits and receives in that way, what happens when the car is here? Well, it's not going to work. So actually for a car, you need something that is not fixed like this antenna. You need something that can talk to the car wherever the car is, whether it's here or here. So that isn't a requirement for automotive applications, and this still isn't 5G.
The clown says that, these 5G doesn't operate in the spectrum. Well, that's just basically another lie. Sub-gigahertz frequency spectrum considerations in 5G Europe. Look at the numbers, people. These people are lying to you.
Yeah, the numbers don't include 868 or 869 megahertz mark, which is where the Harvard devices operate. So Mark's found a document that disproves what he's trying to claim. So it's interesting. So Mark has just told us that 5G operates at 868, 869 megahertz. And yet here we have a document entitled Frequency Spectrum Considerations for 5G in Europe, which doesn't mention the frequencies he said 5G works on.
All right. That's just continually lying. 3GPP completes first 5G standard. So 3GPP, all right, you have to remember when that started. All right, significant number a year ago, right, which was the start of the 5G deployment, right?
Okay, so let's look at the 3GPP. So 3GPP is a 3G partnership project. It is a group of just under 1,000 companies and universities and other establishments and tens of thousands of people that have come together in a partnership to develop the standards for mobile communications to be used globally. But more interestingly, what we have here is a timeline from the 3GPP. This is a timeline of 3GPP releases. So Mark says that this has been going on for a long time, years and years. Well, they have, but look at what the releases are here. So in 1992, it's basic GSM. Then we get GSM with a bit of data, so you can put data on your phone now in 1997. GPRS is actual digital packetized data on your phones. In the year 2000, we have release 99, and that is 3G. So release 99 is UMTS. It's the 3G network. We then move on to having an all-IP core network for 3G UMTS. And we move on down here. We have a bit of a WiMAX here. WiMAX seems to have died now. I was involved in the WiMAX standards groups for a while. Down here, 2011, we have FreeGPP release 10. Release 10 is when LTE first made a real appearance. We had a bit of LTE here in release 8 and release 9, but release 10 is when LTE became a bit better, LTE advanced. But you see, it wasn't here until 2008 that we got LTE released by the FreeGPP. The first LTE networks appeared in the UK in 2012. Again, I built or was involved in building that network. And then down here, end of 2018, we have FreeGPP release 15, which is 5G phase 1 specification. So 5G spec was only really released end of 2018, 2019 really. So not sure what Mark's saying here about 5G standards.
But the dummies just keep on spreading that disinformation. Now let's show you what 5G is, right? You see it's directional. Unlike a 4G transmission that transmits in all directions, omnidirectional, see that? These transmitters are directional.
So Mark has found a bit of a marketing cartoon about 5G here. This is not the whole truth of what 5G is. So 5G is a specification set released by the FreeGPP, as you've just seen. 4G broadcast signals in all directions. Well, so does 5G. Otherwise, how would your device know there's a 5G network? What 5G can do is it can use a technology called beamforming. And what beamforming allows a base station to do is that rather transmitting your data that's going to your phone in all directions on that cell site, so it won't be 360 degrees, it'll be one of the sectors on that cell site. So rather than transmitting your data all over that way, to all these people here and this whole area, it just transmits it to your device. And what that means is that it can use lower power to do that. So rather than using, say, 20 watts to transmit a signal that was only intended for your phone over that whole area, it will use maybe 5 watts or less to transmit it just in a specific direction to your device. And this is good because it means it uses less power, and it means there's less interference on the network for other users using the network. And if there's less interference, you get a better signal, and you need to use less power to get that better signal. So that's what 5G can do. It's not a requirement of 5G. 5G can use omnidirectional antennas, but 5G has the option of using these beamforming antennas. But this isn't new, because beamforming has been around for quite a while. In fact, I installed a beamforming mobile network in 2005 using equipment from a company called Navini Networks, which had a 9-element beamforming array at 3.5 gigahertz. So beamforming is not new. It's just new when it's applied to a mass mobile technology such as this. But even then, some 4G vendors had base stations with beamforming and MIMO. It's not a new thing. This is just a marketing cartoon, Mark. You can do better than that. No.
So you see the autonomous vehicle, that's why in the top of that streetlight it's an 868, because that's the bit that's the spectrum that's been allocated for this autonomous vehicle. That's how we know what was in the streetlight.
So Mark is saying that in 2011, 2012, Gateshead Council were thinking about autonomous vehicles when they installed lighting controllers on top of their streetlights. I don't think they were, Mark. And there's another issue here. So the device which we have, the Harvard device, uses a protocol called WiMAX for its communications. WiMAX is a part of the family of protocols for low power, longish range, low bandwidth, low duty cycle communications. on a LoRa network, you have what's called a transmit duty cycle, which is how often you can transmit. And the highest duty cycle on 868, 869 megahertz for the LoRa protocols, which is part of the LPWAN family, is 1%. 1%. That means that in 60 seconds, that's 1 minute, you can even transmit for 1 whole second in 1 minute. So how are you going to control autonomous vehicles when you can't even transmit to them for a whole second in 1 minute? How's that going to work, Mark?
The equipment was 5G because of the spectrum frequency it operated at.
But we've already seen, Mark, that spectrum is not allocated to 5G. And when they were installed, 5G didn't exist.
I mean, you know, anyway, Harvard launches sensor node. Look, it just says at the back, because lights are brought back to full brightness when someone enters the area. This is urban radar scanning technology.
Okay, let's have a look again at the website which discusses this sensor node device. So yeah, the idea again is that if you walk down a street or an alleyway, then the lights will turn on, so the lights aren't on all the time. This is good. We live in a fairly quiet street here, and the lights are on all the time. They don't need to be. They're just wasting electricity and shining it into my bedroom window, so we have big, thick curtains to block the light out. It would be great if the lights were dimmed and then only came to full brightness when a vehicle or a person was in the street and needed the lights turned on. But again, we see on the website here that this is not built into the sensor node. It is an external device which connects to the sensor node. The device operates via connection with an external presence detection unit. So it's got nothing to do with this, Mark. This is not a urban scanning radar device. Something needs to plug into it to detect people.
Because that's how we can see people entering into the area. Also, as the director's document says, for automotive. I mean, it's just beggars belief how dumb these people are.
It's interesting. Look at the data on there. It's 2014. Again, long before 5G was a thing.
Where do they get them from? Well, let's show you where they get them from. What is LoRa? Short for long range. All right? Short for long range. That's what LoRa stands for. Short for long range. Makes pretty sense, doesn't it? So let's just see what this clown pad store, Craig pad store, obviously he's a dog. He's got a picture of a dog there. I know he's not going to put the pictures up of his cross-dressing, but he has the picture of his dog. He said, no up-816 is used for low power, short-range applications such as LoRa. Hang on, what does that say, Craig? Short-range applications such as LoRa. Interesting, because that means long-range, Craig. You need to stop dressing up. I don't know what sort of lipstick you're using, but you need to change it.
So I've spoken to Craig a few times on Facebook. I'm not sure where Mark's transphobia is coming from here. If Craig dresses up in dresses and puts lipstick on, that's his business. Maybe Mark likes that kind of thing, and maybe he's fishing for a date here. I'm not quite sure why that's relevant. But okay, so let's have a look at the 868 megahertz spectrum again. Non-specific short-range devices. So what Craig actually said here is that 868 megahertz in EU is used for low-power, short-range applications, which is exactly what the Ofcom spectrum map says here. Now, LoRa is indeed capable of long-range applications when it's line of sight. So when you can see the transmitter from the receiver. Then you can get to sort of maybe 10, 15 kilometers, which is great because that means you can use LoRa for monitoring remote water stations or remote power systems, substations, for example. But in an urban setting, when you have buildings all around you and sort of clutter such as vehicles moving around and all that kind of stuff, and people's houses and things, the range is much shorter, and you might get a kilometre out of LoRa, depending on what the clutter is around that area. That's all Craig was saying there.
WiMAC, this is the antenna, all right, that allows you that long range capability, because obviously it's a microstrip antenna. It only radiates from this side out over. You may get some leakage, however.
Well, that's wrong. We've already looked at that, haven't we? And my other videos completely disprove that. And so does MC Tunes. It is not a microstrip antenna because microstrip antennas don't look like that. And it's omnidirectional, which has been proven by my video when we spun the device around and looked at the signal strength in all 360 degrees. Maybe Mark didn't see that video. I'm sure we commented on it. Maybe he didn't understand it. I'm not sure. But while we're here, let's have a quick look at LoRa, shall we, and what the applications of it are. So this is the website from the LoRa Alliance. LoRa WAN specification is low power, Mark, wide area networking protocol designed to wirelessly connect battery operated things to the internet in regional, national, global networks. It doesn't have to be the internet. I wouldn't want street lamps here connected to the internet. That doesn't sound like a good idea to me, but they connect to the local council so they can control the street lamps. That is what LoRa is. LoRa is very low power. Okay, so let's have a look at the LoRa documentation, shall we, and see how much power you can transmit. So this is the LoRa spec here. You can again have a look at this if you like. I'll put the link down in the description under the video here. In Europe, for example, when using the ISN band frequencies 863 to 870 megahertz, users must comply to the following rules. For uplink, i.e. from the device that Mark has here, that I have here, the maximum transmission power is limited to 25 milliwatts. 25 thousandths of a watt is the maximum that device can transmit. Okay, so it's very low power, Mark, and it's omnidirectional. Let's say that on the antenna here, on the device rather than that antenna, there was a highly directional antenna, such as a Yagi, such as the one in the website here. This Yagi has a gain of 23 dB. Okay, decibels we add up, it's very simple. So 23 add 14 is a grand total of, are you going to beat me to it? 37. So let's see what 37 dBm is in watts, shall we? Let's see if you have that big antenna, which is about 1.3 meters long. Let's see how many watts you'll be transmitting from the antenna, just in the direction it's pointing at, which should be quite narrow. And the answer is, so it's about 5 watts. But you're only putting 25 milliwatts into the antenna. All it's doing is narrowing that down, because that's what directional antennas do. And so the effective power, if you're here right in front of the antenna, is like you were transmitting 5 watts omnidirectionally in all directions. That's what the gain of an antenna means. So even if it was a high gain antenna, which it isn't, then you're still only transmitting 5 watts and still only in that very, very narrow direction there.
It mainly is directional from this side of the PCB board. Pretty straightforward. I hope people can get that.
If it's so straightforward, why does Mark get it so wrong?
Here's an industry document, shows the antennas on the top of the streetlights. You see that, everybody? Directional.
So what Mark's done is he found some sort of cartoon somewhere. All it signifies is that lamppost is talking to another lamppost. This is not a technical document, Mark. It's not making any implications about the directionality of the antenna. Yeah, it's a cartoon. It's a marketing cartoon.
Now, if these clowns want to show me what a directional antenna looks like, because we're waiting for the pictures of them, we have them, we know what they are, but these dummies just don't. But they're in a panic for a reason. This trolling is bizarre for a reason. So anyway, we'll put this up on YouTube. Let's see how many Brigade 77 thumb it down. Let's see how many more fake profiles, they can put up.
So when Mark says a fake profile on YouTube, what he means is a YouTube account with no content. Most YouTube accounts have no content. All it means is that you've logged into YouTube with either your Google account or another account you might be able to log in with, so you can put comments in. That is not a fake account. That's just an account with no content.
To try and keep the sheep herded, right, away from realising that your local council's fitted a target acquiring weapon system to the street furniture outside your bedroom. They just don't like it, do they?
So Mark thinks that Gateshead Council has fitted a targeting weapons system from the Chinese onto the lampposts in Gateshead in about 2011, 2012. This is, surely, this is a Doctor Who plot, isn't it? So there we are. That's Mark's video. I won't go through it all again to summarise. You see what he says. You've seen the reality, and they don't quite meet up, do they, Mark? So yeah, I'm looking forward to Mark's next video, which I will also debunk. Have a good morning, afternoon, evening, or night.